Welcome to Mafia, a new podcast telling stories of America's criminal underworld.
Gotti assumed the position of head of the Gambino family.
And using the name Donnie Brasco, I was able to infiltrate the Bonanno crime family in New York City.
Bugsy Siegel is an American mob legend.
One man changed the whole texture and landscape of crime in America.
Listen to Mafia every Wednesday on Apple Podcasts or wherever you get your favorite shows.
Today's episode of Space Nuts is brought to you by Moonshot, a new podcast from Lawson Media. Find out more at www.moonshot.audio.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on Space Nuts, the astronomy podcast with me, Andrew Dunkley, your host, and of course from the Australian Astronomical Observatory, Fred Watson. Hello, Fred.
Hello, Andrew. And that's actually a codpast is quite a good way to put it, really, isn't it? It's
Did I say codpast?
No, you didn't. But,
Oh.
I thought you were going to. Our regular codpast about space things.
Well, you know, there was astronomy in medieval times, so they probably had codpasts.
They probably did.
Boom, boom. Today, Fred, we're going to talk about how to weigh black holes. I'm thinking intergalactic scales, but I could be wrong. We're also going to look at the Galactic Internet to talk to aliens. Okay, that's starting to sound like, A, relying on the internet for anything, and B, how do we know they've got ADSL? And a bag full of nothing. Well, almost nothing. Sells for a pretty penny. We'll find out about that. First up, Fred, how do you weigh a black hole? This has got me rather intrigued.
It's a great story, Andrew, and it kind of segues on from something we were talking about either last time or the time before. I can't remember. I think it was two editions ago, which is about the fact that astronomers, whilst we see black holes which have similar mass to the sun, maybe 10 or 20 times the mass of the sun, and we see black holes that have got millions or billions of times the mass of the sun, and they're in the middle of galaxies, we don't see anything in between. The so-called intermediate mass black holes, which have masses of 100 to 100,000 times the mass of the sun, are not found. We don't know of any. And so last time we spoke about this, we were discussing a mechanism by which those black holes might have grown to be the size of the monsters, and the speculation was that you will only see them in the early universe. In other words, when the universe was much younger than it is now, maybe half the age it is now. It's 13.82 billion years, by the way, just to give you an age. We celebrate its birthday on Monday.
Oh,
so. Or actually any day, because we don't know the day. I've got a personal theory, Andrew, which I might have rehearsed before with you on these conversations, that one day we will know the date of the Big Bang, and I bet you a quid it turns out to be April the 1st, and that will really
or February the 29th.
Yeah, that's right. Set the cat among the pigeons. Anyway, back to reality. The news that we are talking about today is it's a paper that's published in one of the most august journals of astronomy, the monthly notices of the Royal Astronomical Society, and it's about a really interesting relationship that has been uncovered between the way a galaxy looks and the mass of its central black hole. And this, it's unexpected. That's the correct answer, right? Because why should there be a link between the way a galaxy looks and the mass of its central black hole? And just to cut to the chase, the answer to that question is that the suggestion is that black holes and galaxies basically evolve alongside one another. We've had this debate as to which comes first, the black hole at the center of a galaxy or the galaxy itself. And this seems to be pointing towards the idea that the two basically grow in sync. They actually grow together.
Okay.
Galaxies, of course, are these huge aggregations of stars and gas and dust and something called dark matter. We live in one called the Milky Way galaxy. Its mass is about 400 billion times the mass of the sun, which gives you an idea that there's a lot of stars in it. So it's quite a big one. And we also have a moderate-sized supermassive black hole at the center of our galaxy. It's about 3.6 million times the mass of the sun. There are ones that are much bigger. Some are billions of times bigger than the sun. But this new research gives us a way of actually checking that. So what astronomers have done is taken the sample of known supermassive black holes at the centers of galaxies, and it's not a big sample because, as you can imagine, galaxies being very distant objects, or at least much more distant than the local stars that we can see in the sky. In order to weigh a black hole, you've got to do some very careful observations. In fact, what you do is you look at the motion of objects around the black hole, or the swirling disk of gas and dust around it, and that reveals how much it weighs. But that's a very difficult observation to make. And you can really only do it for the most nearby galaxies, which means galaxies that we're seeing more or less as they are today.
So galaxies that aren't far, far away.
Exactly. Exactly. Not galaxies.
You do realise that every week
away.
I'm trying to get a Star Wars reference in there. I'm like Jerry Seinfeld always had a Superman in every episode of his show. I'm trying for a Star Wars reference in every episode of ours.
Yeah, okay. Well, look, that's all right. If we get some, if we get some support from the franchise, that'll be very good indeed.
That'll be all right.
So, in a galaxy not far, far away, in other words, one that's nearby, we can actually measure the mass of a black hole fairly accurately. But the new research shows how we might extend that to much more distant galaxies that really are far, far away, maybe 6 or 7 or 8 billion light years away. How can we do it? Well, the relationship that has been discovered, it's actually something that's been known for quite a while, but has been really refined in this work. It turns out that when you look at a spiral galaxy, and that's one of these sort of pinwheel-shaped galaxies with beautiful trailing spiral arms that swirl around, when you look at one of those, you can actually measure what's called the pitch angle of the arm. And in other words, it measures how tightly wound the spiral arm is. Okay. And you can picture this fairly easily. Some galaxies have got very loosely wound spiral arms, and I'm doing the motions with my hand, which I'm sure you can see.
Yes,
and I hope our listeners can as well in their imaginations. Some galaxies have spiral arms that are loosely wound. Some are wound up like clock springs, really, really tightly wound. And it's the pitch angle that determines the difference between those two. But it turns out that if you measure the pitch angle, it gives you a measure of the mass of the black hole. Work that one out.
Like the hub of a wheel versus the
size of the
tire, or the
size of the hubcaps or something. Yeah, that's right. This comes from measurements of actually 37 black holes that have been measured in galaxies that aren't far, far away, the nearby ones. And they get this relationship that says that the looser bound a galaxy is, then the bigger the black hole is at the center. So, and they've actually basically give a formula that relates the mass of the black hole to the pitch angle. And the bottom line in this, and I guess the punchline in the story, is that if you want to find intermediate mass black holes, the ones that have been mysteriously missing to date, you've got to look for galaxies with a pitch angle of about 26.7 degrees.
And let me guess, we haven't found any yet.
Well, that's not actually that's where the story stops. So what's happened now is, because this paper's just been published, you can bet your life astronomers everywhere are saying, right, let's get into the data, looking for these galaxies with pitch angles of that in their spiral arms. So there will be follow-up work on this very, very soon. Maybe our listeners could do a bit of citizen science here, because there are plenty of places on the web where you can download hundreds of thousands of images of galaxies. The Galaxy Zoo is one such place to look at. And yeah, you might just be one of the lucky ones who finds a galaxy with a pitch angle of 26.7 degrees that then goes on to turn out to have an intermediate black hole.
Of course, we could also be looking for something that doesn't exist.
You could, exactly so, because the intermediate black holes have been conspicuous by their absence. But if you want to go and have a look for one, well, plenty of places to go and look, and remember where you heard it first on Space Nuts.
Plenty of space to look in too, yes.
Indeed.
All right, we'll watch with interest. There might be more on this story down the track. Who knows? You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
Okay, Fred, to the controversial world of the internet. And somebody's come up with an idea that we should probably start to consider in terms of talking to intelligent aliens, because we haven't found any form of life anywhere beyond Earth at this point in time. So intelligent life beyond Earth is even a bigger stretch for the moment. But people think it's time to, gear up for the possibility, or whatever. So the words Galactic Internet have been put on a headline, and of course that's got everybody buzzing. Or getting cut off in droves, which is what happens here, but that's a different story.
You think your internet's slow, Andrew. This one, it's the suggestion as to how long it will take to build it is 300,000 years.
Oh, good grief. Well, it depends whether they use fibre or copper.
Maybe so, or just space in this case.
Well, if they're thinking wireless, they're wasting their time.
Well, there you go. I mean, for all the internet is a pain in the neck sometimes, it is what allows you and me to do these segments.
I know. I'm only half joking.
We've got to be grateful for small mercies. So this story, it's really about a thought experiment more than something that is, going to result in immediate practical activity. It comes from a colleague in actually the University of St Andrews, which is a university very close to my heart because that's where I was educated back in the 1850s.
And this is what they've come up with. Gee.
So this suggests that. So okay, picture this: you've got a galaxy like ours, which is populated or dotted by civilizations, alien civilizations. That it to my mind is a fairly big stretch of the imagination anyway, because I think we might find that intelligent aliens are relatively rare, but that's another story. And just let's imagine for the time being that they are commonplace and they're dotted throughout the galaxy. How do you communicate with them? And so the suggestion that's been made by this author, this colleague at University of St Andrews, Duncan Forgan, is that you could build an internet that would use the light of your parent star as a way of signaling to space generally, broadcasting a signal out to space that could then be picked up and passed on by another alien civilization. And the result being that you build up a network of transmissions using the light of your parent star. Now, that brings us to another segment of the issue, which is that in order to do this, you've got to be very patient indeed, because even if you could send a signal from our planet to the next nearest star, apart from the Sun, and that's Alpha Centauri or one of its companion stars, that's a time that, or an interval that's going to take 4.2 years for the signal to get there, another 4.2 years for it to come back, the reply. So that means you've got to wait basically 8.5 years for even the nearest star to be in touch with you. And that's, one question and one answer. So it is a slow process. But what Duncan has been more interested in is the technology that you might use to do that. Because I suppose ideally what you'd like to do is use the sun with some sort of shield in front of it, so you could send out Morse code to the alien civilizations. But that seems incredibly impractical. And so he's gone back to a suggestion that was made maybe a year or so ago, and I think you and I might have talked about this. And that is that if you're on a planet like the Earth, going around the sun, periodically, if you're looking from outside, from a distant, a distant star, you're looking at the sun. You don't see the Earth because it's too far away. But what you see is a tiny drop in the intensity of the sun when the Earth passes across the sun's disk. It's called a transit. Mm-hmm. And that's actually the way we've discovered most of the known planets around other stars. We've looked for the dip in the star's light as the planet passes in front of its disk. So, but now go back to the Earth. Okay, now what you do is as the Earth is crossing the disk of the sun, you flash really powerful lasers off in the direction away from the sun, and they're so powerful that they mimic the blob of sunlight that you're taking out by the Earth being in the way. So you send a laser off into the wide blue yonder that sort of compensates for the slight drop in intensity. And so what you create, to any person looking from the right direction, they see the Earth, the sun's light dimming slightly as the Earth passes in front of it. And then they see a series of sort of blips on that as you compensate for it with your laser beam. It's a fairly complicated process, but it does provide a way of signaling to other intelligent civilizations. I think the lasers that you'd need to do that don't exist yet, and probably won't for quite a long time. So it is still a thought experiment.
So basically what we're doing is waving intergalactically.
Yeah, intergalactic waving, that's right, which we don't do at the moment. Effectively, we are relatively silent. We've sent out radio beams into space, but by the time they get to even the nearest star, they're so weak that it's really hard to detect them. This is in contrast is a more powerful method of doing it. The kind of bottom line of this, though, is that supposing now that it's not us trying to do this, but it's another intelligent civilization that is waving in this way, well, we already have the wherewithal to pick that up if they are doing, because the Kepler spacecraft itself has been, as I said, watching for the dip in a star's light as planets pass in front of it. If you watch those dips, and we do very frequently, it's a big industry in the world of astronomy and space. If you watch those dips and you find little blips on them of the kind I've just described, then that tells you that, yes, somebody has thought of this before and is trying it out with their laser on a planet around a distant star. Sadly, so far, we haven't seen anything like that.
No, we haven't, no. Well, I'm kind of relieved, because when you started talking about Galactic Internet, I was worried about us flooding the intergalactic fibre optic system with porn. But it's good to know that won't happen. We'll just be waving. But we probably should use emojis. I think that'd be a better way to do it.
Yeah, the problem is, what does a smiley face look like to an alien? They might see that as a declaration of war.
You never know. Well, I certainly do. You never know. You never know.
Yeah.
All right. Well,
maybe you're an alien too.
We will again watch with interest, but maybe there won't be much movement on this one in the near future. But I love the theory. You're listening to Space Nuts with Andrew Dunkley and, of course, Fred Watson. And this episode of Space Nuts is brought to you by Moonshot. Moonshot is a new podcast from Lawson Media that explores seemingly impossible technology ideas and the people trying to make them happen. Now, these are ideas that might just change the world as we know it. The show covers topics like self-driving cars, Mars space travel, artificial intelligence, and even the people trying to integrate technology with your body and your mind. You can find the show on Apple Podcasts or wherever you get your podcasts. More information on the show can be found on their website, www.moonshot.audio.
What a matchup! And what a team, Mike. Metro PCS and the iPhone SE for $0 on a network that covers 99% of people in the U.S. Oh, impressive.
Play with the best. Switch to Metro PCS and get a 32-gig iPhone SE for $0. Metro PCS. Coverage not available in some areas, plus sales tax and $10 activation fee. Claim based on talk and text. Not valid for active numbers currently on a T-Mobile network or active on Metro PCS in the past 90 days. See store for details and terms and conditions.
Roger, you're loud and clear here also.
Space Nuts.
Finally, Fred, we're going to look at a bag of nothing, or almost nothing, that has just sold for, quite a lot of money. I won't reveal that yet. That can be what people anticipate, although you're probably going to tell us straight up. But this bag is very special. I saw this actual story pop up in the news not so long ago. It's got a fascinating story behind it. And I think there was actually a legal battle over who actually owned this piece of property at one stage. So what's this bag full of almost nothing all about?
Yeah, an empty bag being auctioned at Sotheby's, the New York branch, actually, of the Sotheby's auction house. Cut to the chase, this is a bag that went to the moon. In fact, it was the outer decontamination bag from the Apollo 11 mission, the first flight that landed astronauts on the moon. Neil Armstrong and Buzz Aldrin, enshrined in legend by all of us who are interested in space, and in particular by space nuts. So the Apollo 11 mission landed July 1969 on the lunar surface, Sea of Tranquility. Mm-hmm. Of course, the first of 6 moon landings, so there were the first 2 of 12 astronauts who walked on the moon. As with all those lunar missions, Neil and Buzz brought back samples of rock and soil from the moon. The lunar soil is called the regolith. That's the technical name for what's just dirt, basically, on the moon. They brought samples back, and by the end of the Apollo missions, I think something like 370 kilograms of soil and rock samples had come back to Earth, which, of course, is a scientific bonanza for anybody researching planetary science. And those samples were spread all around the world to various scientific institutions, and 1 or 2 of them went to be diplomatic gifts and things of that sort. So that's all good stuff, and that's all very, very well documented. But apparently, when this bag came back to Earth, having been to the moon, it was left in a box at the Johnson Space Center, rather than being sent, as with all the rest of the equipment, to the Smithsonian museums. So this bag was left in a box. That was because of an inventory error, so somebody didn't tick it off. And then some years later, there was a government auction of junk, right. Government surplus stuff.
And this bag was in it.
It was misidentified. Yeah. Empty bag up for sale. And somebody bought it for just short of $1,000. This was in 2015. It was a lawyer from Illinois who bought it. Apparently, and you're quite right about the court case, at NASA were a bit miffed about this. This is a bag that's got traces of moon dust in it, because it does, and it's gone for $1,000 to Illinois. So they indeed took out a court case to try and get the bag back, but the judge in question ruled that it legally belonged to the buyer.
Yeah, they lost. Whoa.
They lost, yeah. And so that means that somebody had the good fortune to have an empty bag that had been to the moon, offered it for sale at Sotheby's, and sold. For
their $1,000 investment, they made
$1.8 million. Not bad, is it? Not bad.
That's amazing. That's amazing. Gosh, I love stories like that.
Yeah, and it's gone to an anonymous bidder. So we don't know whether it will wind up in a museum, whether it's in a private collection. We don't know what's happened to it. But we do know that it's worth $1.8 million.
I've done a bit of digging, Fred, and I've found the name of the buyer. It's one N. Asa.
I know him or her. Sorry, could be no.
No, we don't know. We have no idea. But somebody's got quite a piece of human history now. Really, they have.
It is. That's right. Because you and I both agree that this is perhaps the pinnacle of human achievement in terms of our exploration of the natural world and the universe. It's the first celestial body other than the Earth that humans have walked on. What a triumph for technology.
Yes, indeed. And it might remain that way for quite some time, because the talk now is that missions to Mars might just be too expensive, and that's probably going to be put on the back burner for the time being. So
yeah, I think that's right. I think there's still, 2035 is the date that we've been looking at for the first NASA Mars landing by humans. Maybe it will get pushed back. It's a very difficult thing to do.
Well, it'll have to now that they've spent $1.8 million on the back of moon dust.
Yeah, there you go.
See, conspircy theories. I'm constantly coming up with them.
It's funny. Those are exactly the words that came into my mind.
Yeah. Oh dear, very good. I love that story, Fred. That's a ripper. And yeah, so for $1,000, making $1.8 million. I don't know what the court case cost him, but might have been worth it.
That would have been worth it.
Thank you, Fred. Lovely as always to talk to you.
Good to talk to you. All the very best.
And as Fred fades away into the ether, this is Andrew Dunkley signing off from Space Nuts for another week. Thanks for joining us. Don't forget to listen to us online through your favourite podcast platform, whatever it may be, and Space Time with Stuart Gary as well. And we will catch you next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.
And today's episode of Space Nuts was brought to you by Moonshot, a new podcast from Lawson Media. Find out more at www.moonshot.audio.
From Audio Boom comes Covert, a new podcast that delves into the murky world of spies, soldiers, and top-secret military operations. I'm Jamie Rennell, and together we'll discover the real stories of history's greatest classified missions, told by the operatives, soldiers, and journalists who experienced it firsthand. Follow Covert on Spotify, or subscribe now on Apple Podcasts, Stitcher, or wherever you find your favorite shows.